Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, we will see problem solving on buckling and safe load, means how to find the buckling and safe load. In this video, we will see. Okay, so this is the lecture topic. So now let's see the question. First, a hollow alloy tube. Actually, this is the question. Okay, or you can just put here question. Okay, a hollow alloy tube from 4 meter long with external and internal diameter of 40 mm and 25 mm respectively was found to extend 4.8 mm, a tensile load of 60 kilonewton, right? Find the buckling load for the tube fixed with both in pin, right? So here just see what is given, like a hollow alloy tube from 4 meter long. So L is given as 4 meter, okay, with external and internal diameter, that capital D is given as 40 mm and small d, that internal diameter, is given as 25 mm respectively, was found to extend 4.8 mm. So delta L is given, that got extended by 4.8 mm. Okay, a tensile load of 60 kilonewton. This is capital L. So load is given, that P is 60 kilonewton, or you can say 60 into 10 to the power 3 Newton. Now what is required? Find the buckling load for the tube fixed with both in pinned condition. So now just see here the condition is, so this is very important. Depending upon only you can take the crippling load formula, that equivalent length. So here that is given for both ends is pinned. Also find the safe load on the tube taking a factor of safety as 5. So factor of safety you have to take that as 5. Okay. So now solution, I don't know why it's not coming. It's a solution and references and from here. So just see what is given. Length of the tube as 4 meter, external diameter as 40 mm, internal diameter as 25 mm, right? So just see capital D 40 mm, small d 25 mm, factor of safety as 5, delta L 4.8 mm, that buckling load. So just see I already told whatever is given or what you have to find, right, that also. Now just see, after seeing this, no need to read the question again, or you just go to the previous slide. Means with directly we can find from here what is required, and with that what we can find or which formula we have to apply. Okay, so our condition is both ends are pinned, right? So in that case what happened? LE will be equals to L. In both the case, both in fixed, LE is equals to L. So equivalent length is equals to same as the length given. So that, and how much length is given? That is 4 meter, right? So now if we are taking all the other things in mm, so this L is equals to 4000 mm. Okay, so this is 4000 mm. Now buckling load, right? That PCR. So PCR is equals to what? Pi square EI by LE square, or LE is equals to L here. So simply we can write that as pi square EI by L square, right? Here pi square is not required, that is constant. E is given, right? So let's see here. Okay, and I is required. We have to find the I. So for that finding I, only this is given. So what is the formula for I? Right, for hollow, that is pi by 64 d power 4 minus capital D power 4 minus small d power 4. So that only the formula you have to apply here. Okay, so just see. So first step will be what? To find the moment of inertia. Okay, so let's see to find the moment of inertia. So now moment of inertia is pi into d power 4 minus d power 4 by 64. So just see here in this question also, E is not given here, right? Means that E also is required to find. So how we will find that E? For to find the E only this is given, right? So just see how we will find this one. So first let's find I. So I will be equals to what? Pi into, or just simply I is equals to pi by 64, right? d power 4 minus a small d power 4. So after substituting, what we will get I equals to pi by 64 into d is how much? 40. So we are, keep in mind that we are taking in mm, so all the distance should be in mm only. So 40 power 4 minus 25 power 4. Okay, so after solving this, what you will get the value of I as 106,500. Okay, so 1,06,500 mm power 4. Now we have the moment of inertia. Now next, what we have required, that we have to find what? Okay, so let's see first here. Now first we require to find what? E. So what is E from the Hooke's law? What Hooke's law says? That strain is directly proportional to stress, and from there only strain is equals to E into stress. Sorry, stress is directly proportional to strain. Stress is directly proportional to strain. For this proportionality constant, one constant is required to remove this proportionality. So stress is directly proportional. So that becomes equals to E, that Young's modulus of elasticity, into strain. Right. So now strain is what? That we have to find. So, okay. So now let's see here. So I'm writing, what is stress? Stress is force per unit area. Okay. That is equals to E into strain. Okay. Epsilon, or simply. So what will be E? E will be equals to F by A into this epsilon, that is strain. Okay. So now what is a strain? That E is equals to delta, E is equals to delta L by L. Right, that strain is equals to change in length by original length. So change in length is how much given, that, or simply you can just write here, then we can put. So E equals to F by A into delta L by L. Right, after substituting. So that delta L will come to the numerator. So E is equals to F into L by A into delta L. Right. So now we have the formula for E to find. Now just see, F is given or P is given if you are taking in terms of P. Earlier I mentioned here that as P, so you can take that P into L or F into L. So that just P or F is load here or force. Okay, so now put the value. So E equals to F. F, how much it is given? That, let's see here. F is given as 60 kilonewton. So here F is missing. So F is 60 into 10 to the power 3 Newton. Okay. So now just put the value. So 60 into 10 to the power 3 for F into L is given how much? 4,000. So 4,000. Right. So F L over divided by A. A is given as 765. Okay. 0.8 into 10. Sorry. That 0.8 into delta L is given as how much? Delta L is 4.8. So just see here, delta L value. Delta L as 4.8 mm. Okay, so delta L is 4.8 mm. Okay, now just solve this one. What you will get after calculating this? What you will get? That E equals to 65290, that is 65,290 Newton per mm square. Okay, so now we have the value of E. So now once we have the value of E, now come to the previous equation, that pi square EI by LE square. Now we can find. So buckling load will be equals to what? Buckling load or PCR is equals to what? Pi square EI upon, let's see here, this formula, that LE square, right? So LE square, but here LE is L, so pi square EI upon L. Okay, now everything we have to put the value. So pi square into E, how much we got? 65290 into, because just already we are taking an mm, so that 10 to the power is not required. Everything we are considering in mm only. Into now 1 106, that value of I, 500. This is denominator part divided by L. L is how much? 4000. So now this one, this two, this one. Right. Now what is left? That pi square into 6529 into 1065 divided by 4. Okay. So now let's see here. After putting pi square EI, pi square 65290, value of E, I as 106500, and LE square is there. That LE square, sorry, here L square is there. Right, because LE square here I miss. So this whole square. So here more 3 zeros will be there. Okay. So now after putting this value, just see here, for pi square into 65290 into 106500. So this is the value of E, this is the value of I, divided by L is what? 4 meter it's given. So 4000 square. So after solving this, what you will get? 4.4290 Newton. That we can write as 4.29 kilo Newton. Okay. So now this is what? The Euler's buckling load. Now what is the next? To find the safe load. What we have to find? We have to find the safe load. So factor of safety is what? Factor of safety is buckling load by what? Safe load. So from here, safe load, what we have to find? So just write safe load equals to what? Buckling load divided by factor of safety. So how much we got the buckling load? Just put that value. Buckling load is 4.29 kilonewton, or 4.2 into, let's write 10 to the power 3 divided by factor of safety is given as 5. Right. So after solving this, what you will get? That 858 Newton. That we can write in terms of kilonewton. Then it's 0.858 kilonewton. So this is the safe load. Means what? Up to this load, if you will work or if you will apply, then that structure will remains constant. Means it won't break. More than that, then chances are there to get cracked or to get break. So let's see quickly once again what is given here. Okay. So hollow tube is given. That means tube dimension is given. How much length is there? 4 meter. Then outer diameter is given as 40 mm. Inner diameter as 25 mm. And applying load, that F is given as 16. That tensile is 16 kilonewton. Up to this is fine. But here that extension also, that is elongation also is given. Right, that delta L is given as 4.8. So this delta L help us to find what? The value of E, because in this question E is not given. That Young's modulus of elasticity is not given. Okay, now what is the question? Buckling load for the tube fixed with both in fixed. So both in fixed gives the LE value. What LE value you have to take according to the given condition. So in this case, it's a both in fixed. So LE will be equals to L. If it's one in fixed, then it will be 2L. So depending upon what condition is there, that condition you have to take for the equivalent length. Okay, and also what is required to find the safe load when factor of safety is given. So just see here. Okay, given length, that is, or you can write this as how much? 4000 mm. This is given D as 40 mm, 25 mm, factor of safety 5, delta L 4.8, buckling load what, and E is also equals to what? That is because E is not given, right? So then I required, because according to this formula I also is required. So I equals to what? Right. So just see whatever is required that we have to find. So E and I both in pinned. So means L is equals to L and 4. So now just see E required, I required for finding this equation. Now how we will find the E and I? I directly we can find from here. I is pi by 64, d power capital D power 4 minus small d power 4. So for finding I there is no issue. Directly we can find. That already we found. Now the thing we have to find E. So what we will do, we will apply the Hooke's law, that one E, right? So that sigma is equals to E into epsilon, that is strain. So from here E equals to sigma by epsilon. What is epsilon? Strain. Strain is what? Delta L by L. So here this we can write F by A for stress divided by delta L by L for strain. So this becomes FL by A, okay, delta L. So now here A also is required, right? For this formula, A also is required, and that A we can find because already inner diameter and outer diameter is given. So let's see how you will think to solve the question. So first write all the given data, then write with that data whatever the things is given, and if anything is missing, just like here E and I is missing, then how to find E and I with the given data, then find the missing term from the given data and then substitute in the final equation. Okay, so now just see here. So first moment of inertia after just putting this one, then area after putting just area is what? Pi by 4 capital D square minus small d square. So this one. So now we got area. Now everything we have. So first find E. So from here, just now I showed you that E will be equals to FL by A delta L. That is here FL by A delta L. Now everything you have, F you have, L you have, A also is here, and delta L is given. Right? Just substitute the value. So F, then L, then A, and here that is given. Let us this one delta L value. After substituting, what you will get? The value of E. So now we have E and I. So once you have E and I, what we can do? Just substitute in the given formula. Which formula? That PCR equals to pi square EI by LE square. That's all. So just see here, it's given. Since the column is pinned at its both ends, therefore equivalent length of the column LE will be equals to L is equals to 4000 mm or 4 into 10 to the power 3 mm. Right. So after substituting here directly, what? Just see here in the formula. So pi square, then value of E, then value of I divided by LE, that is L square. So after simplifying, you will get 4,290 means 4,290 Newton, or you can say 4.29 kilonewton. So first answer over. Now the second answer is what? To find the safe load, means up to what load we can apply so that the structure or that column works properly, that without failure. So for that, what is the formula? The factor of safety is buckling load by what? The safe load. So just from there, what we can find, that safe load is buckling load by factor of safety. So buckling load is here, factor of safety is here. So the buckling load is 4.29, safe load is 5. So 4.29 by 5, that is 0.858 kilonewton answer. Okay, so that's why just see how many things we had seen. First, write, that means write all the given data by reading at the same time. Reading, once you get the data, write down what is given. Next, what you have to do, write down what is required, that what they are asking in the question. After that, what you have to do next, just see in that question how we will find the formula of that one. In that formula, what are the things is missing. So like in this case, E and I was missing. So what we did, we found this with the given data only, you have to find. It's not like that you can choose anything. With the given data only, you have to find those missing things. Once you found those missing things, just put into the final equation and get the answer. Okay, so this is my reference. You can refer here for the solution of this question. If you have any doubts or anything, just comment on the video. I will clarify your doubts, or you can simply contact me directly. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.